All right, welcome students. In today's video, we're going to take a look at inequality statements. We're going to take a look at some of the differences between inequalities and equations. And then we're going to take a look at how to actually write out all the different solutions that exist to an inequality statement. Before we get started, how many letters are in the alphabet? Oh, that'd be 11.
Wait, what?
Yeah, there's 11, not 26, because the alphabet. T is 1, H is 2, E is 3, alphabet, A, L, P, H, A, B, E, T. If you add up, that's only 11 letters in the alphabet. Okay, anyway. Get it? If you spell it out, the alphabet, there's 11 letters. Never mind. Okay. So looking at our first thing, we're given a Venn diagram here. And I want to take a look at the difference between our equation and our inequality. So first of all, let's look at our example. It says x plus 3 equals 5. That is an equation. We know it's an equation because it has an equal sign. Okay, so it's an equal sign because, it's an equation. It has an equal sign, so we can obviously see it is an equation, right? All right, let's take a look at, and then our inequality here, we see we have this symbol, which is the greater than symbol. And sometimes we see the same, right, that's greater than. Sometimes we see this one, the less than symbol, right? Equation, of course, means that both sides are equal. They're the same. And inequality shows that one side is either greater than and that's this guy right here, that's the greater than symbol. Or we see that it'll show that it's less than. And that's that guy right there. Sometimes we see them like this, where it's less than or equal to, or greater than or equal to. But the or equal to is where we see that sometimes those inequalities can be the same. It can be like an equation. And that's if that has that line underneath. All right, so when we look at this equation, x plus 3 equals 5, and we think about, all right, what value or values makes that statement true? Well, what number am I adding 3 to that gets me to 5? The only answer that works there would be x equals 2. X can't be any other number than 2. 2 is the only solution. So this only has one solution. There's only one possible answer that makes that true. And that is true of almost all equations. Now I say almost all, it will be all of our equations that we deal with here in 6th grade. Once you get up to 8th grade, you will see some situations where you might have equations with no solution or infinite solutions. But for our equations here, an equation will only have one solution. And I'm going to put a little asterisk next to that because some equations might have more than one solution once you get into older grades. Okay? All right. Let's look at our inequality, though. X plus 3 is greater than 5. Well, so first of all, can x equal 2, right? Does that work? If I say x is equal to 2, well, 2 plus 3 is 5. Is 5 greater than 5? The answer is no. So that does not work. But any number that's greater than 2 will work, right? X could be 3, and then 3 plus 3 is greater than 5. X could be 4, X could be 5, right? Any value that's higher than 2 will work. So what we really want to say is that X can be any number greater than 2, right? It can be any number greater than 2. Well, how many numbers are there that are greater than 2? Well, infinite. There are an infinite number of solutions to that inequality statement. And because there's infinite solutions, we just represent that by actually writing an inequality that is the solution to our inequality. So when we say x is greater than 2, this is actually the answer. X, meaning any number, will work that is larger than 2. Does 2 work? No, because that is not a number that's larger than 2, right? So these values, they have to be bigger than 2 in order for them to work for this inequality. Okay, and just a quick recap, we write our solution to an inequality with another inequality, which can be kind of confusing, right? All right, let's go down and take a look at our examples here. So when we look at, it says write an inequality to represent the possible solutions to each inequality. So here, I'm going to be trying to find the solutions to this inequality here, which is n plus 3 is greater than 12. Well, my first question to myself, and we're going to go over how to solve these using inverse operations, and we're going to get there. But for now, I really just want to figure out first which one will make those equal, right? So if I think about that, what number can I add 3 to and get to 12? Well, you could add 9 plus 3 equals 12, right? So if I replace that, 9 plus 3 equals 12. And then my next question is, does that 9 represent a solution to this inequality? And the answer is no, right? Because if n is 9, so n cannot equal 9. Whoops, not m. Sorry about that. N cannot equal 9, right? But I know it's got to be bigger than 9. Right, because 9 makes it equal 12, and it says that it's got to be greater than 12. So any number that's larger than 9 will make that greater than 12. 9.1, right? 9.2, 10, 1,000. Any number bigger than 9 will work. So my answer to this inequality is to write my inequality that is my answer. N is greater than 9. Any number larger than 9 will represent an inequality for this, or will represent a solution to this inequality. So could n be 12? Yes, because 12 plus 3 is greater than 12. Could n be 50? Yes. Could n be 9.1? Yes. Any number bigger than 9. Could n be 8? No. Right? It's got to be a number that's larger than 9. All right, let's take a look at part B here. It says 5 is less than or equal to n minus 2. Okay, so now I'm asking myself, what number can I subtract 2 from and get 5? And the answer to that is 7, right? Because if I say 7 minus 2, well, that's equal to 5, right? So that actually works. Because of this or equal to, that line at the bottom, it means that my solution of 5 equals 5, it works, right? So n could be 7. And I just know that my value for n has to be at least 7. So if I look at writing this, there's 2 different ways you could write this. You could put the 7 over here and write it like this, which is totally fine, meaning that n is 7 has to be less than or equal to n, or you could write it like this. If you put the variable first, you would say n is greater than or equal to 7. And both of those work. Both those are solutions. We're saying any number that's higher than 7, if I replace n with it, will work, right? So n could be 7, it could be 9, it could be 27, it could be 1,000, right? Because that's going to give me something that is larger than or equal to 5. All right, these are kind of tricky, right? When we're talking about solving an inequality or representing the solution to an inequality, we're going to use another inequality to represent those potential solutions. Okay, thank you very much for watching. Hopefully this was helpful. Make sure you're doing the try this on the bottom and the back, and then enter your answers into Schoology. Thanks, and have a great day.